Okay, well, today we are talking about quotients, right? And quotients really the fancy math language for an answer to a division problem. So that's really what we're going to be talking about today is like our understanding of quotients. Now, we're going to kind of start off in the foundations, like the kind of beginning of quotients and what all of this means. And we're going to start with this idea of one of my favorite math vocabulary words, and that is inverse. So today we're going to be talking about the inverse operation. So it's kind of, well, operation, sorry. But that's what I was going to get to. Let's talk about that idea of what an operation is, right? What is an operation? That's our first step. We understand what an operation is, then we can talk about the inverse, and then we can talk about division. So let's talk about operations, right? And I'm not talking about going to the doctor and getting an operation. I'm talking about math and the operations we find in math. In math, there are, I will use letters, but there are 4 operations that we use for absolutely everything that we do with our numbers, right? So the first one we might use, and it's in no order, like this isn't the absolute first, it's just the first we'll talk about, is addition, right? So addition is one of our operations. So now that I've said that, I wonder if some of you are already thinking, oh wait, I do know what these operations are, right? So addition, why did I pluralize that? Addition, right? It's just a thing. Okay. And then we have subtraction. Right. Okay. Subtraction. And then we have multiplication. And again, there are many different ways we can write the multiplication symbol. And then we have division. So like these are our 4 operations. And when we're talking about the inverse, we're talking about the ones that kind of have this fact family part to them, like this connection. Right? So like, okay, addition and subtraction, they're like the fact family. They have a connection to one another. And multiplication and division, they also have a connection with one another. So what I mean by that even, so let's dive into that, is like, let's think about 3 plus 5 equals 8, right? So the fact family of all of this tells me then, well, 5 plus 3 also equals 8. And then if we think about, that was the addition part, if we think about the inverse, then we would be doing what is generally, I think, a key word to help is the opposite. If I'm going to add something, the opposite of that is to subtract it. So the rest of my fact family might be 8 minus 5 equals 3, and then 8 minus 3 equals 5. So that's the addition part of it. If we thought about the inverse and the opposite of multiplication, that could be that 3 times 5 equals 15, which means 5 times 3 equals 15. And then that inverse, that opposite, would be division. So 15 divided by 5 equals 3, or 15 divided by 3 equals 5, right? And all of these are just a representation of what we like to call the fact families, right? So a fact family. These are the fact families. So that's kind of like just the beginning of it all. Like, what do we know about the inverse operation? Meaning, how is it that we can use the opposite operation to solve things that we know? Which now takes us to this back to division and that word of quotients. Fancy word for answer to a division problem. So let's break that down. Let's just start with something. Let's take a division fact. Let's take 42 and divide it by 7. What do we have, right? Okay, so if we think about the inverse of all of this, right, to help us solve it. Like maybe I don't know 42 divided by 7. I don't know what it equals. But I could think about, oh, well, if I use the inverse operation, I can look at it the other way around. I can say to myself, well, that's something that I'm unsure of times 7 equals 42. So I could think about, well, what are my strategies there? Well, I know what I understand of multiplication is that I'm doing groups of 7, right? Or I'm skip counting by 7. So I might even be able to just do that. Maybe I'll lay out the multiples, right? And lay out the multiples of 7. And if you don't remember multiples, don't worry, we have that video for you to watch. But I'll just list out the multiples of 7 until I get to 42. So 7, 14, again, multiples, I'm just skip counting, right? 7 times 1, 7 times 2, 21, 28, 35, 42. There it is. So how many times did I have to do that? Well, 1, 2, 3, 4, 5, 6, which means with all that information I just gathered, that means that 6 times 7 equals 42. Therefore, according to the inverse operation in fact families, 42 divided by 7 equals 6. So here's a really cool way I can help myself solve these division problems. Let's do another, right? Always just trying another one. Let's do, boy, I'm having a hard time thinking today. Let's do 24 divided by 6. Okay, so that equals something. Who knows? So maybe I don't know. So let's go back and use that inverse. So first let's inverse, right? So let's flop it, meaning let's change the color for that. So let's see. So that just means that something times 6 equals 42. So there we go again, right? We're using this idea of the inverse. I was dividing, now I'm gonna flop it, I'm gonna inverse it and try to multiply it. So if I wanna solve that, well, that just means we gotta think about our 6's. So let's do our multiples of 6's, right? We're gonna skip count 6 times until we get to 42. So 6, 12, 18, 24. Look at this. Oh my goodness. Maybe I haven't had enough coffee yet today. Let me fix that. Boy, you were probably the whole time screaming at the screen like, dude, come on. That was 24. You're right, it's 24. My fault, not 42. That was the last problem. Or was it? All right, so we're going to 24, and I already did. So that's 1, 2, 3, 4 times. So 4 times 6 equals 24. Therefore, the inverse or the fact family tells me that 24 divided by 6 equals 4. Okay, so minus my little mistake about flip-flopping those numbers, don't inverse that. I hope this is starting to make a little sense. Like, how can we then solve division problems using multiplication? So let's do it. Let's do a couple more. I'm going to do this one. And again, this is that point at which you can pause the video and try these. And then, you know, I'll walk through them and we'll see how they work. 30, no, you know what? Let's do this one. 27 divided by 3. Okay, so let's just do those two first. So go ahead and give that a go. I'm going to dive right in because you're now coming back from the fact that you paused this video to figure this out for yourself. So let's start. So I know right away 36 divided by 6 equals something, right? So I got to figure out in the inverse that that's something times 6 equals 36, which means I can use my groups, my multiples of 6. So 6, 12, 18, 24, 30, 36. Okay, so how many times did I have to do that, right? Times, multiply, inverse, all that. How many times? I did 1, 2, 3, 4, 5, 6 times. So that tells me that 6 times 6 equals 36. Therefore, according to the fact family, 36 divided by 6 also equals 6. So there would be the answer to A. All right, let's try this second one. 27 divided by 3 equals something, or something times 3, again using the inverse operation, equals 27. So we're using our groups of 3 until we get to 27. So 3, 6, 9, 12, 15, 18, 21, 24, 27. There it is. So how many times many times did I do that? 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So 9 times 3 equals 27. Therefore, 27 divided by 3 equals 9. So there you have it, right? Inverse operation. Such a great tool to use. And it's really going to help us if we can think about how to solve division problems, which means, right, that really just means let's use multiplication in order to solve division. So I hope that worked out for you. Again, check out the assignments and things that go with this. Post questions, ask. We're going to continue to work with it. As always, thank you for your hard work, and we'll see you super soon.